Hey guys, today's project is one of those projects I couldn't talk fast enough to get out of. What the customer wants is to take this 4-stroke motor and adapt it to an outboard, like propeller drive. So he's got an old 2-stroke outboard motor that the motor part of it's bad, but the propeller and the vertical shaft is fine. So he wants to adapt this motor to drive that propeller basically. And so what he did is he cut the end off the old crankshaft on the old motor, and he wants to adapt. It's got an internal spline. It's a 6-key internal spline right here, and he wants to adapt it to the end of this crankshaft. So that's the project for today. And the way I'm going about it is I actually purchased this off-the-shelf machinable coupling, and it has the proper 7/8 bore to fit the crankshaft. And then this end here, when it comes in, is 1/4 inch, and I've bored it out to 20 millimeter, which is the outside diameter of the old crankshaft. And so that's ready to go together. And now the task is to key each part of this. So there's a 3/16 key here, and then I'm probably going to try to put an 1/8 inch key into this little shaft. The problem is that this shaft is case hardened, so we may or may not be successful with that. If I can't cut a key in it, then I'll just rely on the clamping force of this coupling. Okay guys, I won't bore you with how I actually did the machining, but I will explain the setup because it's a little bit interesting. So what I did is I just took this piece of stock, it's 1 3/4, and I just turned a stub on the end that is 8/72. That's the same diameter as the crankshaft. The crankshaft measures out 8/72. And then I can take this coupling and slide it onto that stub and tighten down this side of the coupling, and then it's rigidly attached, and it has theoretically perfect run out to the chuck. Then it's really hard to drill through the coupling because it's split, so I plunged it with a 1/2 inch end mill, and that works pretty well. This coupling, the coupling's made from some kind of leaded steel, probably 12L14. It's really easy to machine. And then I did use a stack of shims, and I just slipped it into the groove here and tightened down the screws onto this shim pack before I did the boring. And then you can see I just bored it with one of these little Criterion brazed carbide boring bars, just taking 15 thousandths on the diameter at a time. And like I said, it's leaded steel, so it's really easy to bore. So this is a 1 thou indicator, and you can see I've had it on and off a couple times now, and the total run out is about 1,000th. So that's definitely what we want. Alright guys, I'm getting this slotting attachment set up in order to cut this blind keyway, and I couldn't figure out a way to square the bottom, or square the tool to, you know, so that it's perpendicular to the center line. So the best thing I came up with is I've got a scale, and I'm just sticking it in on top of the part, and then pinching it between the cutting tool and the top of the part, and then, you know, level the scale, and I can sight along this scale to the T-slots, and as long as it's parallel to the T-slots, then it should be perpendicular to the center line. And then I used my little threading fishtail gauge again down here in order to align this slot that they cut with the T-slots in the table. Okay, I've got my stroke adjusted so that the tool just clears at the top and just touches the edge of this clearance hole at the bottom. So that's the purpose of this hole, is to basically be a relief at the end of the key. And it's a 3/16 key, so we need to go half that. So what's that? 0.95, something like that. So we might go a little extra. And here we go. Again, we're on the slowest speed. I'm not super familiar with this machine, so we're going to take it real easy. So that's 90 thousandths. We're going to stop there and take a measurement. So here's the dramatic conclusion. This is the key. It's been fitted to the shaft, and then this is the coupling here, and you can see that keyway as it came off the slaughter. That's excellent. And that having that hole at the bottom as a relief, that worked out perfectly. I thought about, you know, cutting a groove at the bottom, but that hole was a lot simpler, and yeah, you can't complain about that. So that goes on there. And then normally I would drill and tap a hole for a set screw to hold the key, but this is a vertical shaft application, so I don't think it's an issue here. I guess if the key, well, actually the key can't come out anyway, because there's not enough room in the shaft here for it to walk all the way out. And then on the stub shaft end, I intended to key this as well, but whatever this material is way too hard to machine. It must be like an 8630 or I don't know, 4340 or something. And so even when you get through the case hard layer, it's still super tough and nasty. So I just set it up and ground a flat on it, and then I'm using a set screw onto the flat, and I think that'll be fine. I use a lot of side lock end mill holders in my machining center, and you know, they don't even have this clamping feature. It's just a tight fit and that one set screw, and I can almost stall my 15 horsepower machining center with a tool holder like that. So I don't think it's going to be a problem at all. So that's it, and another happy customer.